So question number 3 is, I'm interested in finding out the length and width of the rectangular prism sleeve the pods are sitting in. If the radius of one pod is 2.1 centimetres and there are 10 sitting on top of each other, what's the total length and width of the sleeve, assuming there is a 0.8 centimetre gap around the entire inside of the box, as space for the pods to slip out when you want to use one. So at the very start of the CAT, I've actually got images showing what the sleeve looks like. So it's quite thin, it's not wide. So I'll attempt to draw it here. Okay, so that's what a sleeve looks like. And remember that a pod looks like this. Okay, now each pod is in the shape of a hemisphere, which is this. So let's think of it as a 3D half circle, okay, which obviously this one is 2D, but a hemisphere is a 3D half circle, okay. Now I've just drawn a 2D version. From here to here is 2.1 centimetres, okay. So if I turn this into a full circle like this, then it would be, the radius would be 2.1 centimetres this way. The radius would then be 2.1 centimetres this way. And then the radius would also be 2.1 centimetres this way. And then the radius would also be 2.1 centimetres this way. Okay, so from here to here, from here to here, from here to here, from here to here, it's all 2.1 centimetres because the radius is 2.1. Okay, so if I drew that circle again, then all across here, I'd have 4.2. And then all across here, I'd also have 4.2. Okay, does that make sense? Our radius is 2.1, but just because we view a circle looking down in it like this doesn't mean that just from here to here is 2.1 as a radius and here to here is 2.1 as a radius. It actually still applies above and below, because I could easily turn my page like this and look, now we're looking at our circle like this again. Okay, so the radius actually goes right, beneath, left, and above. All right, now knowing this, if I just redraw this as the hemisphere of the pod, that means that from the bottom of the pod, because remember I just elongated this to show you, so the bottom of the pod to the top of the pod is 2.1 centimetres. So that is 2.1 centimetres. And you've got 10 of these sitting on top of each other like this, because the pack holds 10, stacked all on top of each other. So if you've got 10 of these like this, all right, all the way down to 10, that means you have 10 lots of pods that all have a 2.1 centimetre, let's say, height. Even though that's technically not correct, but can you see that? Because the radius is 2.1, all right, the radius is 2.1, so half of the circle is 2.1, but that means that this half of the circle is 2.1, that half of the circle is 2.1, and if this was a whole entire circle, it'd be 2.1 from here to here and 2.1 from there to there. So it's 2.1 all around. But we're only dealing with a hemisphere, which is half of it. So we only care about these measurements. This technically doesn't exist, but I just drew a full circle to prove a point. Okay, so that means if we have 10 lots of these, for the height, we've got 10 lots of 2.1 centimetres. So 2.1 times 10. because we've got 10 pods in a sleeve. So that equals 21. All right, this is 21. The pods all lined up on top of each other in the packet makes it 21 centimeters long. But then remember in the question it said that there's a 0.8 centimeter gap on each inside to give the pod space to slip out. So on the bottom and on the top, there's also an extra 0.8 centimeters each, okay? So there's an extra 0.8 here and then an extra 0.8 down the bottom after the 10 pods. So we need to add on 0.8 and 0.8 for that extra space for the pods to slip out. So plus 0.8 plus 0.8. And then that will give us the whole entire height of the sleeve because we're factoring in the gaps on the bottom and the top. Okay, that's 0.8 centimeters. So that equals 22.6 centimeters as our height. All right. Now, if we do the width, all right. Now, this time, what are we going to do? All right. We've got 2.1 centimeters up here. Now, this time when we do our stacking of the pods again, I'll just stop at 4 because I'm not going to draw 10, but imagine there are 10 of them. I said to you before that the radius was 2.1. So half of this was 2.1. Okay, this is 2.1. But then this half here is also 2.1. So we have another 2.1 from here to here. Okay, so every single one of these has a radius of 2.1 from here to here, and then the other half from there to there. So the diameter of our hemisphere is actually 4.2 because 4.2 is the whole way across. Okay, so the diameter of our hemisphere is 4.2. Now inside the sleeve where it sits, there's also a 0.8 centimeter gap on each side to let the pods slip out. So to work out the width, we'd do 0.8 for the gap plus 4.2 for the whole diameter of the pod, or you could do 2.1 plus 2.1, and then plus the leftover 0.8 as the other gap. Okay, so we'd add 0.8 for the gap, 4.2 for the diameter of the pod, or 2.1 plus 2.1, and then plus 0.8, which is the remaining gap on the side of the sleeve. And that gives us 5.8 centimeters. So the answer for the height is 22.6 centimeters, and the answer for the width is 5.8 centimeters. Okay, question number 4. What's the volume of the sleeve? Well, we've got a rectangular prism, so what's the formula for the volume of a rectangular prism? Well, it's length times width times height. Okay, and I'm just going to draw, well, try and draw again the sleeve. Oh. Like so. Okay, so we said that the height from question 3 was 22.6, so it's 22.6 centimeters from there to there. All right, from here to here, that's our width. What did we say that was? 5.8. all right? And then obviously no matter which way that we look at the sleeve, the diameter and the radius of the pod is always going to stay the same no matter what angle you look at. So remember the drawing that I drew up here, every single radius from every angle that you look at it is always going to be 2.1 centimeters. So judging by that, no matter which way that we flip the sleeve and we look at it, this is going to be the same measurement. It's also going to be 5.8 centimeters because you're just looking at the pod from an angle like this now instead, as if this was the front, okay? So from there, I'll just use a different colour. We'll just go length. It actually doesn't matter which way you label everything because it'll still equal the same in the formula, but all right, we'll go, oh, because technically I should have made that the height, that's all right. 22.6 times 5.8 times 5.8. Put that in your calculator. Equals write this so you don't lose half a mark. Okay? Now, I know that I said that it doesn't matter what you label what, because the formula is just all multiplication. So no matter what you call your length, your width, your height, you'll still get the same answer because you're just multiplying. So I hope that doesn't confuse you. I might even just change that so it doesn't. I might just make that the length and I'll just call this the height, just in case you get confused. But it doesn't matter because you're just multiplying in the formula, so you still get the same answer.